Hi, this is the next video for Year 13 Maths, and it's teaching to work towards exercise 11B. We're looking at integrating functions that look like that, a function of ax plus b. Now, to get your head around this, you need to be all over the chain rule for differentiation, because effectively this is the reverse of the chain rule for differentiation. So example 3, integrate cos of 2x plus 3. Well, I know that sine differentiates to cos. Remember, integration is the opposite of differentiation. So sine differentiates to cos. So what happens if I differentiate sine of 2x plus 3? Well, using the chain rule, sine differentiates to cos, and then I multiply by the derivative of the bracket. So that's 2 cos 2x plus 3. Well, that's nearly what I want, look, except it's twice as big as I want it to be. So if I halve both sides, I'm going to get what I want. So the integral of cos 2x plus 3 is a half of the integral of sine 2x plus 3. So I do these by considering what happened when I differentiated an appropriate expression, and generally I fix it with this constant, multiplying by a constant. Part B says the integral of e to the 4x plus 1. Well, I know that e to the x differentiates to e to the x, so consider differentiating e to the 4x plus 1. Chain rule, e to the 4x plus 1 times by the derivative of the bracket, 4e to the 4x plus 1. And of course that's 4 times as big as I want it to be. So this must be a quarter of the expression that I differentiated. And part C, sec squared 3x. Well, I know that sec squared is on the standard list, so I can use the list in a formula booklet and consider what happens when I differentiate tan 3x, because of course tan differentiates to sec squared. Oh, that was weird. A lorry just hooted as it went past. Hang on a sec. Sorry about that, had to calm the dogs down. Anyway, tan differentiates to sec squared. And of course the chain rule says you then multiply by the derivative of the bracket, which is 3. So this is 3 times bigger than I want it to be. So my integral is a third tan 3x plus c. Now, spotting that, this is we'll call it the reverse chain rule. Spotting that I need to use the chain rule to integrate is the real skill here. So there's a statement in the book that says, it says this: f dash ax plus b equals 1 over a f of x, f of x plus b c. I don't know that this is particularly helpful. What it's saying really is, if I recognise that this is the result of something that I differentiated using the chain rule, then I differentiate and fix it with a constant, and that's my constant there. So I think this is less useful than developing the skill of, did I use the chain rule to differentiate this? Example 4. (1 over 3x plus 2). Well, clearly I'm going to integrate I'm going to rewrite this as 3x plus 2 to the minus 1. And I know that log of x differentiates to 1 over x. Useful to write it like this because look, if I increase the power and then divide by the power, I'm going to get 0. So this rings a little alarm bell. It's clearly not anything to do with integrating the power and dividing by the new power because you can't divide by 0. So I'm going to consider what happens if I differentiate the log of 3x plus 2. Well, that's log goes to 1 over, and then I multiply by the derivative of the bracket. So that's 3 over 3x plus 2. Well, this is 3 times too big, so it's got to be a third of log 3x plus 2. Writing this line was really just to demonstrate that this is not a increase the power divided by the new power, so we really don't need that line in our solution. We go straight from there, recognise it's a log, try the differentiating, and then fix it with a constant. Whereas, of course, this one, 2x plus 3 to the 4, this is increase the power divided by the new power. So let's think about what happens if I differentiate 2x plus 3 to the 5. Well, differentiate the whole thing, bring the power down, reduce the power, and then multiply by the derivative of the bracket, which is 2. So this is 10 times 2x plus 3 to the 4, which is nearly what I want, but it's just 10 times too big. So it's a tenth of 2x plus 3 to the 5 plus c. Just remember in the back of your mind always, what I'm trying to do here is the opposite, undo the differentiation, the opposite of differentiation. So I'm always asking the question, what did I differentiate to get here? And I know it must have something to do with 2x plus 3 to the 5. So if my power is not -1, then I'd just increase the power divided by the new power as I normally would. Okay, have a go at 11B, please. Let me know if you need anything, and I'll see you soon.